Good afternoon. We're going to talk about normal distribution. So this is step 6 in the data analysis instruction. So we will go over how to analyze if the data is normally distributed. And before we talk about the procedures of going over that data, what I'd like to do is give you a little context, and just to remind you, there's a reasoning of why data needs to be normally distributed, and it relates back to the concept of our data analysis, or our data question and data analysis. So as you all know, we have 4 basic types of variables, and Dr. Fleischer will talk about that a little bit later. But specifically, continuous and discrete or numeric data is what I've been focusing on. Dr. Fleischer is going to talk about ordinal and nominal data. But these numbers, we need to make sure before we run statistics on them, if the assumptions that we know that need to be met are actually met. And that's sort of the focus and the issue that we want to make sure you understand. So descriptive summaries are great, but we also need to make sure that they meet the normal distribution of that data. So box plots or scatter plots for correlational data and histograms are really helpful for us to see what we think is going on, but eventually what we actually need to do is we need to confirm that we do or do not have normal distribution to decide on which statistical analysis. So this is a simplified decision tree based on the type of data. Do we have categorical or ordinal data that Dr. Fleischer is going to talk about, or then quantitative or numeric data? What's the type of question? And so far I focused everything on differences, so we'll deal with relationships as we progress through this, but everything right now is related to differences. I know this is a busy slide, but sort of work with me here. So blues are parametric analysis, reds are non-parametric analysis. So if we have 2 or more groups, we're going to do different analyses. So if we're looking for differences or relationships between samples, typically differences, and they happen to be independent, then we're going to do an independent or a 2-sample t-test. If this assumption of a parametric statistic has to be met to make sure we perform the correct analysis, and that's where understanding normal distribution is. If the parameter is not met, we have a backup. We can do non-parametric analysis, but we need to determine if the data is meeting certain assumptions. And this is true for all of these 2 groups and multiple group analyses. So those assumptions you're sort of taught in statistics class. Some of you have had that, some of you have not. So just as an introduction, so it needs to be numeric data to do t-tests and analysis of variance, so that has to be met. We hope, based on what Dr. Heather Bush presented, is that the data is relatively random and representative of the population. And then we have to determine if the data is normally distributed or not. And that's the key, the normal distribution of the dependent measure, that measurement that we're actually capturing in our research analysis. The larger the sample, this is more likely to occur. So we really have to check on this when we have small n's like 15 and 20 and 25. The other assumption is that we need to have equal variance. There are some corrections that can be done in some statistical analysis for unequal variances, but that is the fourth assumption of most statistical parametric analysis. So again, we have non-parametric versions of this if we need to. So now, for an example, so this is a project that I'm working on with some physical therapy and athletic training students. We hypothesize that patient-reported outcomes will decrease significantly from initial visit to discharge. This is sort of a repeated measures design. So we expect discharge scores to be lower than initial dash scores following a radius fracture, meaning our therapy is effective. So it needs to be numeric data. We get that from our quick dash score, which ranks from 100 to 0. The lower the score, the better the function or the less disability they have. We're going to take a random sample from a group of clinics in our population. We're hoping to get a couple of hundred of samples. So as our sample creeps over 100, it is not as critical to have a perfect normal distribution. Sometimes analysis of variance or parametric measures can overcome that. But it's nice to be able to demonstrate that we do or do not have a normal distribution. And so for data points or data groups that are under 50, you might want to make sure you graph with a histogram that we already showed you, or report a test of normal distribution, which is often called the Shapiro-Wilks test. So the assumption of homogeneity of variance can be done by looking at the variance around the mean, so the standard deviations related to that measure. So I'm going to show you how you can generate in SPSS this kind of printout where it gives you standard deviations and variance, and you can sort of see here in yellow where I've highlighted the standard deviations at initial and at discharge are nearly identical. They're within 3 points. The variance is comparable. It's about 100 units apart, but this would probably be considered equal variance. And then obviously we already talked about the distribution. At the initial, there's a bit more of a normal distribution, but it's a little bit more skewed at discharge, which is good because it's skewing toward people getting closer to 0, which means they're getting better. And so then we would have to go back and check, or we could check, the Shapiro-Wilks test. And so now that's what I want to walk you through, is how do you actually do that in SPSS. If you already know how, great. If not, this will be good for you to learn. Okay, so we have our SPSS data, and what we're going to do is we're going to analyze this data using the function called explore. Explore basically gives you descriptive data. Of course, it moves it over to the other side. There we go. It gives you descriptive data, but you can also do tests for normality. So again, in the document that I gave you, I said in class we would do posterior deltoid pre and post. So we're going to measure them before they do their rehab and then again after. And then in your homework you're going to do the same thing, but you're going to do it for a couple of muscles. The additional thing we'll talk about here in a second is that I want you to interpret the result of the data. Alright, so we want the posterior deltoid, and we want to look at their average strength, baseline before we do it, and their normalized baseline strength. Remember, this is the average of the two trials. This is divided by their body weight, so it's taking into account how big the person is. Then we want to do the exact same thing post-intervention. So we're going to have the average strength post and the post-normalized posterior deltoid strength. Now we want to do that by group. So if you go back and you look at the explanation, for each group separately using the average and normalized data. Now, when I showed you how to do this as frequencies, I split the file, but because excuse me, but because the data has a factors list, which is the independent variable, this is the dependent measure, these are our measurements, this is our independent, I don't have to split the data, it will do it as part of the analysis. So I'm going to put my group in here. So now I have all of these by group. I want to run the appropriate statistics, everything's going to show up over here. It's going to automatically give me descriptive statistics. These are other functions within SPSS that I'm not going to talk about right now, but those can be clicked on and you can sort of see what that gives you. I'm not asking for that at this point. But I am asking you to give me, cancel, there we go, normality plots with test. So it automatically plots them and it does normality. Now this is another way, wasn't the way I showed you before, but this is another way to give you histograms. So if you want to do your histograms this way, there's nothing wrong with that. It should give you basically the exact same data. It's just analyzing it a little differently. Or it's not analyzing it differently, it's just another option. Just like with Microsoft Word or Excel, there's 3 or 4 different versions or ways to do basically the same task of copying or pasting or those activities. Same thing with SPSS. More than one way to generate a histogram. Okay, so now we hit continue, and now we hit OK. It takes a few seconds to run these analysis, and then it generates it. So if we look over here on the left side to start with, pull that over. The explore function is run. It gives me what data set am I using. This is from my SPSS, and then it breaks them out by my group. So it gives me my overall group summary. It used all the data that I had available. I had 14 in the healthy, 9 in the injured, and then it basically goes through the descriptives. So this is the This is the pre-posterior deltoid average, the pre-normalized posterior strength, the post, and the post-normalized. And this explore function gives you every kind of descriptive statistic. So you could use this to run that analysis that I showed you at the very beginning. You can see it gives you a lot more information than you might want, which is fine, but it's just another way to calculate the descriptive data, which is really important to know what your data looks like, see if you have any weird outliers, see if there's anything going on with that. And this whole presentation of this data is basically giving you more than one way to start looking at your data. So then, after you get through the descriptives, you look at the test of normality. And so for the test of normality, the posterior deltoid average and deltoid and normalized deltoid strength in the post are run with 2 analyses. We're going to look at the Shapiro-Wilk, and what it's doing is it's asking the question, is this data normally distributed? And if it is normally distributed, it is not significantly different. So what we're looking for here is when the data is not normally distributed, the value of the significance would be less than 0.005. So if we look here, posterior deltoid average strength is below 0.009. Here, looking at the pre-posterior deltoid average strength of injured, it's 0.41. So it's pretty clear that that is more normally distributed than that. Or even, if we look up here, it's not quite significant, but it's close. The very first measure of posterior deltoid average strength is sort of skewed. It's not completely skewed, but it's nearly not significant. And right below it is the histogram, so you can sort of see that it's sort of skewed toward the values of 15 and 20, and we don't have that nice bell shape. But if we look at the injured population, this is all the healthy. So if we look at the injured for that, we'd have to go down to the injured group, which is right here below. So now you can sort of see it's a little bit more of a bell-shaped curve. You only have one person above this 20, but that sort of gives that curve, and that would agree with this value. So this data, what I'm asking you to do is you're going to copy this and put it in your Excel work tab. So this will be your third work tab. Paste it, define what this is, and I've already done that on just to make this a little faster. So this is the normal distribution. I sort of highlight that 0.09, and I want you to give me all the graphs for that, for the healthy and the injured. But for example, on this video, here's the pre-average. It's sort of flat. That goes along with this 0.079. Here's the pre-average of the injured group, a little bit of a normal distribution. And then I went on and put the posterior deltoid average strength after intervention that is definitely not normally distributed, and you can see how much it's skewed off to the left here. Now, in my instructions, it's not just good enough to run the analysis. When you're writing up your research, when you're writing up your statistical section, you're going to have to interpret your finding. So this is my introduction for you to start to write out a statement as you would in a manuscript, as you write out an explanation of why did you do what analysis. You have to identify that the data is or is not normally distributed, which is going to drive you down one of two roads. If it's normally distributed, you can use parametric data. If it's not normally distributed, you got to use non-parametric analysis. So, on the same Excel spreadsheet, write out the interpretation of the normality test to describe which statistical method is appropriate to analyze your strength data. So, just below your graphs, what I want you to do is to write out an interpretation. So the interpretation is all tests were normally distributed except for one. So all of these met the Shapiro-Wilk of not being below 0.05. Only the post-intervention posterior deltoid average strength was not normally distributed. So, therefore, to use parametric analysis only, which type of data would I be able to use in my analysis? I'm not going to give you the answer. You should think through that and come up with the right answer. So now I can, because this data, I can either use the average strength or I could use the normalized strength. Based on this analysis, I can make an interpretation of which type of data I want to use to report my results. So now when you do that for your homework assignment, you're going to go and rerun that analysis. It's very quick and easy, but you're going to do it for the injured average strength data at baseline for 3 muscles. So I'm not going to make you do both normalized and non-normalized, just the injured average for the 3 muscles, upper trap, lower trap, and infraspinatus. So you're going to copy all that information over, put the Shapiro-Wilk in, put the graphs in. Oh, I'm sorry, I'm looking at the wrong one. I apologize. So for the homework, you're going to repeat these calculations for the average and the normalized measures for the 3 muscles at baseline and at post-test. And then you're going to write the interpretation of that data. Stick with the yellow instructions there, Tim. So that should be what you're looking for to do when you do the normal distribution tab. So we've got tab 1 is going to be calculating means and standard deviations, making a table. Step 2 is to do a frequency distribution. I've shown you 2 ways to do a frequency distribution. And then step The next step, the fourth tab, is going to be to review the data and actually write out a quick sentence or two that explains how you would or wouldn't manage this data. So you got to make a decision. Is this appropriate to do normalized or not normal, or I'm sorry, parametric or non-parametric analysis for these tests? So you're going to use both the average and normalized measures when you do this calculation. So I'm giving you a couple options to interpret that data. That is all.